Okay, good morning. In today's lecture, we are going to discuss about state diagram reduction. So let us consider a state diagram and let us see how we can reduce this. So for this, we have two different methods. One is Mealy and another one is mode. So if you see this diagram, you can notice that this is a kind of Mealy state diagram. Because if this is the input and this is the output, see the output depends on the input. In the case of Mealy, the output depends on the input. In the case of mode, the output depends only on the states. We'll be writing the outputs here below the state. So this is a kind of Mealy state diagram, and let us see how to reduce this state diagram. So first let us write the state table for this. Let us write the state table. So while writing the state table, first we have to write the present states. So how many present states are there? If you see A, B, C and D, all together 4 present states are there. I am mentioning it here, A, B, C and D. And now coming to the next state, we have to write the next state. So here the next state, if you consider a state A, we will be having 2 next states depending on whether the input is 0 and whether the input is 1. So see, this denotes, the first value denotes the input and the second value denotes the output. So for every state, we will be having 2 next states. So when x is equal to 0 as well as when x is equal to 1. So we have to fill the next states based on this. So here this is state A, considering it as the present state. When the next state is, when the input is 0, the next state is A itself here. So I am writing A here when the input is 0. And when the input is 1, it goes to B. When the input is 1, it goes to B. So when the input is 1, it goes to B. And also here I am writing the output. So outputs also, since it is Mealy, it depends on the input. So let us write the outputs parallelly. When the input is 0, output is 0 here. When the input is 1, output is 0 again. So I am mentioning as 0. So this is the present state A, for which we have mentioned the next state as well as the output. Now let us consider the present state B. B also will be having 2 next states. One is when the input is 0 and another one when the input is 1. When the input is 0, it is going to the next state C. Here, when the input is 0, it is going to the next state C. Parallelly, the output is also 0 for this case. When the input is 1, it is retaining back in the same state B. So I am mentioning B here, and the relevant output is 1. Similarly, coming to the next state, when the present state is C, the next state will be D when the input is 0. So when the input is 0, the next state is D. And when the input is 1, the next state goes to A. So when the next state is D, the output is 1, and when it is going for the next state A, the output is 1 again. Similarly, considering the fourth state, when it is D, when it is 0, the output is 1. So for D present state, when the input is 1, it is retaining in the same state and the output is 1. And when the input is 1, the output is 1 and it is going to the next state A. So see, for all the present states, we can write the state table. So the state table consists of a present state, next state and the output. Since it is a Mealy diagram, the next state depends on the inputs. So for 2 kind of inputs, that is when x is equal to 0 and when x is equal to 1, we have the state table. So now the next step is, we have written the state table from the state diagram, and now we have to look for any redundant states are there. So for looking into that, let us check the next states and the outputs. If both the next state and the outputs are same for any present state, then we call that as a redundant state and we can eliminate that. Right? So if when the present state is D, again the next state is D and A. Outputs are also same, 1 and 1, 1 and 1. So see these two, that is when the present states are C and D. The next states and the outputs are same, and so C and D are called the redundant states, right? C and D are known as the redundant states. So this redundant states can be eliminated in order to reduce the state diagram. So what can we do? See, we can replace this D by the C. Let us eliminate the state and we can replace D by C. So let me write the next state table after reducing, after the first reduction. So I am going to, what I am going to do is, I am going to eliminate D and replace D by C. Because for D and C, the next states and the outputs are same, right? So I am going to rewrite the state table. So present state. Now D state is not required. So I will be having only 3 present states, A, B and C, for which the next states will be the same for x equal to 0 and x equal to 1 we have to write. So A and B, C and B, here it is D and A. Similarly, the outputs when x is equal to 0 and x is equal to 1, it is 0 and 0, 0 and 1, 1 and 1. Now if you see here, x equal to 0, x equal to 1. So now if you see here, we have eliminated the D state, but here we have a D value, right, as next state. So we have written replace D by C. So I am going to, wherever we have D, replace it by C. All the D's has to be replaced by C. So for the first time, for the first iteration, I have reduced one state. Now instead of 4 states, we have only 3 states. Now look whether any next states and outputs are same. Now if you see here, for these 3 states, no input outputs are common, right? So we cannot further reduce the state, and this will be the final state table. For the state table, we have to draw the state diagram. So now the reduced state diagram. So already we had 4 states. Already we had 4 states. Now we have reduced that 4 to 3. So in my reduced state diagram, we will be having only 3 states. The 3 states are named as A, B and C. So from this state diagram, or state table, we will be drawing the state diagram. When the present state is A, when the input is 0, the next state is A itself. When the input is 1, the next state is B. So when the input is 0, it retains in the state itself. When the input is 1, it goes to the next state. Also, since it is Mealy model, parallelly we have to write the outputs. So 0 and 0 of the outputs. So I am mentioning as 0 and 0. Coming to the next state, when the present state is B, the next state is C when input x is equal to 0 and B when x equal to 1. So C when input is 0 and it is B, it retains in B when the input is 1, and parallelly the outputs are 0 and 1 from the state table. Next, when the present state is C, when x is equal to 0 as input, it retains in C, and when the input is 1, it goes back to A, and the outputs are 1 and 1. Now if you see here, we have only 3 states in the state diagram. By reducing the state diagram, we can reduce the number of gates, wherein we can reduce the cost, we can reduce the power consumption, and all these can be reduced effectively. Thank you.